Welcome back, guys, to our level up series. In the level up series, let us look at one more question. Today's question is trapping rainwater. What does the question says? The question says we are given with n non-negative integers which are representing an elevation map where the width of each bar is 1 and we need to compute how much water it can trap after rain. Let me explain you the question. What we are given is we are given the one array, one vector, which is representing the height of the bars. And the width of each bar is mentioned as 1. For example, the height, for in example number 1, we can see the heights are mentioned to us. For the bar which is present at the 0th index, the height is 0. And the width of each bar is 1. So we can represent 0th bar as like this, because height is 0, width is 1. So we can leave it like in the diagram you can see. At first index, the width is 1, height is also 1. So we have represented it in this way. At second index, the width is 0 as well. Width is always 1 and the height is 0. So it will be same as the 0th bar. Ignore this blue portion right now. Blue portion denotes the rainwater, which will come on later. First of all, I'm explaining with the question how the bars are represented. The width is 1, height is mentioned in the array, which is provided to us in the question. So at the third index, it is the similar condition which is at the 0th index. You can ignore this blue portion right now. At the third index, the height is 2, width is 1. So these black portions are the bars which you can now easily understand. The width is always 1 and the height is given in the form of a vector. So we are given the width and the height of the bars. We have represented it in this way. Now the question asked is how much water it can trap after rain. Now how can we find how much water it can be trapped? For water to get trapped, there must be two bars. Yes or no? One present at the left side, one present at the right side. And if there is any vacant space in between these two bars, then only water can be collected. Yes or no? I repeat, for water to get collected, there should be at least 2 bars. And if there is a vacant space between both of these bars, then water will be collected in that particular pit. Yes or no? See the example over here. For the 0th index, there is no bar present at the left side, so no water can be collected. For the first index, there is no bar present at the left-hand side. Again, no water can be collected. For the second index, we can clearly see that there is one bar which is presented at the first index with height as 1. There is one bar which is, there are many bars which are present at the rightmost indexes, right? But we will take the bar with the maximum height from the rightward index. At the first index, which bar has the maximum height? This particular bar. You can see my arrow. This particular bar has a height of 3. So this is the bar which has the maximum height from rightmost side. So in the same way, from the leftmost side, the bar which has the maximum height is this particular bar of height 1. So how much water can be get collected between these two bars? The bar which has the minimum height, yes or no? So which bar? This 3 and 1. The minimum height is for the 1. So the bar which has the minimum height is 1. And from this, the height of the minimum 1, we will subtract the bar. We will subtract the height of the bar at this particular index. At this particular index, the height was 0. So how much water will get collected? 1 minus 0, which comes out to be 1. In the similar way, I'm showing the dry run for all the bars. Just see it carefully. You will understand it very nicely if you will clearly listen to it. At this bar, which is present at the third index, the height is 2. What is the maximum height present at the leftmost side of it, including it as well? The height is 2. Yes or no? This is only the maximum height. At the rightmost index, for which maximum height is present? This third one, the height 3, which is the minimum of these two. 2, 3, minimum is 2. And from this 2, we will subtract the height of this bar only. So 2 minus 2 is 0. So from this bar, we cannot collect any amount. Next come this bar. Leftmost side, the maximum height is 2. Rightmost side, the maximum height is 3, which is the minimum of these two. 2, 3, 2 is the minimum. From this minimum, we are going to subtract the height of the bar, which is we are looking at present. So 2 minus 1 is 1. So it means it will store 1 amount. Next, leftmost side maximum is 2 again. Rightmost side maximum is 3. Minimum of 2 comma 3 is again 2. And the height of this particular bar is 0. So 2 minus 0 is 0. Sorry, 2 minus 0 is 2. So it will store 2 amount of water. And in this way, for each and every bar, what we need to do is we need to see the height, maximum height at the leftmost side, maximum height at the rightmost side. We have to take the minimum of them, minimum of these two, and from the result which we get after minimizing, we will subtract the height of the bar which we are present at, and we will get the amount of water it will get, the amount of water which will get stored. This is the only thing which we have applied over here in our code. What we did is we have made two arrays, one right, one left. In left array, we are storing for every index, we are storing the maximum height towards its left. And in the right array, we are storing the maximum height towards its right. At left at the index of 0 will always be equal to height at the index of 0. Yes or no? Because for 0th index, there is no bar which is present at its leftmost side. So left at the index of 0 will be equal to height at the index of 0. Then we have iterated for int I equals to 1, I less than size I plus plus. If height at the index of I is greater than left at the index of I minus 1, we are updating, that is left at the index of I equal to height at the index of I. Else, we are doing left at the index of I equals to left at the index of I minus 1. What is this left vector doing? This vector is giving us the maximum height which is present towards its left. In the similar way, what will be the right? What is the right vector doing? It is returning us the maximum height which is present towards its right. So now we have updated the right one. Right at the index of size minus 1 will be equal to height at the index of size minus 1. Why? Because if there are 5 bars, so for the 5th bar, there is no bar which is present towards its right side. So right at the index of size minus 1 will be equal to height at the index of size minus 1. Then we have updated for int I equal to size minus 2, I greater than equal to 0, I minus minus. If this is height is greater, then we will update the right array. Otherwise, right at the index of I will be equal to right at the index of I plus 1. So now in left and right vectors, we have the we have the maximum height towards its left as well as the maximum height towards its right. We have made one answer variable in which we are going to store the amount of water it is going to get stored. Int answer equals to 0. For int I equals to 0, I less than size I plus plus. Int temporary answer. Well, now this is the main thing which we are doing in this line number 39. What we are doing is in temporary answer, min of left I comma right. This left eye is the maximum height towards its left, right eye maximum height towards its right. We are taking the minimum of these two. And from these two minimum, we are subtracting the height which we are currently looking at. This temporary answer will give the amount of rainwater that particular bar is able to store. And then if temporary answer is greater than 0, we are going to add it in our answer. Answer equals to answer plus temporary answer. At the end, we are going to return answer. In our answer variable, we have the amount of water which will get stored. So the question was not at all difficult. If you have listened to the entire video, you all would have understood. We are doing nothing. We are just computing the left, whichsoever bar which we are looking at. We are computing the maximum height towards its left, maximum height towards its right, which is stored in this left eye and right eye. Taking the minimum of these two and subtracting from the current bar. This is the thing which we are. I hope the question is clear to you all. In case the question is clear, don't forget to subscribe to our channel and share it with your friends. Thank you.